In this video we're going to be looking at matrix operations, specifically row echelon form and reduced row echelon form, and we're going to be solving a system of linear equations using these two methods of row reduction. So there are standard operations we can do with a matrix. These are called row operations. The first one is replacement. So we can replace a row with the sum of itself and a multiple of another row. So here we have an example. We are replacing row 1 with row 1 plus 1 times row 2. The next row operation we can do is interchanging rows. We can interchange any two rows. So this example, we are taking row 1, putting it in row 2, and row 2 in row 1. The third row operation we can do is scaling a row. So we can multiply all entries in a row by a non-zero constant. So this example here, we're multiplying row 1 by 2, so 2 times row 1 and 3 times row 2. So let's take a look at an example solving a system of linear equations using these row operations. So here is the system of equations we're going to solve. So these have three unknown variables, x, y and z. So let's take the numbers out of this system of equations and put it in a matrix. We have the variable vector x, y, z, and we have the right hand side. So the first matrix we'll call A. We have the x vector and the b vector for the right hand side. So we need to solve for the x vector. So let's now take a matrix with all these numbers. So we need to augment the A matrix with the b vector by placing a vertical bar in the matrix. And now we're going to do row echelon form and row reduction, reduced row echelon form. So here we're taking row 2 and subtracting 2 over 1 times row 1. The 2 comes from the column 1, row 2, and the 1 is the pivot. We're doing the same to row 3, dividing by the pivot there. So we need to get 0 out column 1, row 2 and row 3. Now row 2, column 2 becomes the new pivot, and we need to 0 out that column 3, row 2, the 10 there. So we divide by the 2, which is the pivot there, and carry out that row operation. We now have the matrix in row echelon form. We now need to do the backward phase and put the matrix into reduced row echelon form. So we need to divide through by 46 to get that leading value in row 3 to a 1. So that gets that 46 to 1 by multiplying by 1 over 46. Now we need to 0 out above the leading number in row 3, so the negative 13 and the 0, and the 5 needs to be zeroed out. So row 1 take away 5 over the pivot, which is 1, and row 2 take away negative 13 over the pivot, which is also 1. That will zero out the negative 13 and the 5. Now the new pivot in the backward phase becomes that 2, so we're moving up and to the left. So we need to make that a 1 by multiplying through that row by a half. And that will become our new pivot. So we need to now zero out that negative 3 above the pivot there. So to do that, we take row 1, take away negative 3 divided by the pivot, which is 1, times row 2, the pivot row. And that will give us a 0 there. We have now reduced the matrix to reduced row echelon form, and we're ready to show the solution. So let's firstly expand this out. So write the left hand side matrix there, the variable vector x, y, z, and the right hand side from the original set of equations. Let's multiply this matrix by the variable vector to get the set of equations, and then we can see the solution for this equation is x equals 2. The solution for this equation is y equals 4. And the solution for this equation is z equals negative 1. Let's check that these values we got are correct by back substituting into the equations, into the original set of equations. So let's put the x, y, and z values into this equation and make sure we get negative 15 on the right hand side. And yes, that works. The left hand side equals the right hand side. That one also works. Left hand side equals the right hand side. And that one also works. The left hand side equals the right hand side.